and then another point on the smaller circle. There you go. So now I try to draw the radius from here to the center, okay, and then from center to the other point of tangency. Good. And then do the same thing here with the smaller circle. Okay. Now, draw it again. Okay. Now, you know what is interesting? Now, if you think about it, this is tangent, yeah? So it is 90 degree, we know that. This one is 90 degree. And this one is 90 degree. Now, if I draw a parallel segment to the tangent, parallel means the same distance. So what will happen, look, if I go from here, I try to do it carefully, like this. Okay. So that is also 90 degree, yeah? So this becomes a rectangle. I'm going to do the same thing here. I go from here, parallel, try parallel to the tangent, something like this. Okay, something like this. And that becomes also rectangle. And we agree that these two rectangles are congruent, yeah? Now, let's draw another line from the center of the circle to the other one. Go all the way here. See what happened? Now we have two right triangles too, because if this is 90, this is also 90 degree. And if this is 90, this is also 90 degree. And these two right triangles share the hypotenuse, which is below. So far, so good?
Yep.
Now let's think about the radii of the two circles. That is y, therefore this is also y. Now if they are parallel, so this chunk here is y, and this one is also y. But what about this small part? How much is that one? Because we know the radius of the big circle is x, yeah? So this small one becomes x minus y, correct? And this one also becomes x minus y. X is the big radius minus the small radius. We get that one. Now look at the hypotenuse. The hypotenuse from here to here is x, and from here to here is y. So the hypotenuse is x plus y. So if this is a rectangle and this is a right triangle, and we use Pythagorean theorem, we can find the missing side, and that missing side is the length of the tangent. Make sense? So I'm going to start with there. We want to find one of the sides. So shall we call it A, so we're not confused? So this is A and this is A. I want to find A, hypotenuse, x minus y squared plus y minus x minus y squared. Is that correct?
Yeah.
So let's expand it, see what will happen. So we have root of, that becomes x squared, yeah, plus 2xy plus y squared minus, this becomes x squared minus 2xy and plus y squared, correct? Then we apply this negative, so we will have x squared plus 2xy plus y squared minus x squared plus 2xy, and then minus y squared, correct? So let's simplify. X squared minus x squared is 0. 2xy plus 2xy,
4xy.
Y squared minus y squared.
0.
Now, what is root of 4?
2.
And what is left inside?
xy.
So sine theta is opposite, which is x minus y, over hypotenuse, which is x plus y. Makes sense? But we are interested in the size of the angle, so we use the arc sine or inverse. So theta equals to sine inverse of x minus y over x plus y. Now, feeling better because we got this part already. We need this. Alpha is, that's 2 pi, yeah, minus pi, and then how many thetas? 2 plus 2 theta, yeah? So let's simplify this one. That becomes 2 pi minus pi is just pi, and then minus 2 theta. That is the angle we want. The arc AB, the length of that arc is radius is y, times the angle. The angle is pi minus 2 theta, correct? Inverse of x minus y, x plus y. Let's check. We got the same thing. We proved that. We show that. That was a nice question.